There are so many options when it comes to 3D printing filament, and I've put quite a few on the table in front of you here. Let's talk about the different types of filament and where you might be using it, and if you stick to the end, we'll show you some of the good stuff. Let's get into it. Hey guys, welcome back to the channel, and if you're new here and you're looking for awesome types of filament, make sure to leave a like and get subscribed because we're going to be going into some of these quite in-depth in future videos, so stay tuned for those. We've got everything from your regular PLA all the way up to some Ultem 9085 that I've had for quite some time. Materials that range as low as less than $20 a kilogram to the Ultem, which is actually over $200 a kilogram. And no, for those of you wondering, your Ender 3 cannot print Ultem stock, just like I'm gonna have a hard time segueing into this sponsor, 3D Musketeers. But before we talk about 3D Musketeers, I need to give a massive shout out to Element 256, one of our Patreon subscribers, who is at the $10 tier or higher and is hanging out in our Discord server. There was supposed to be a different video this week, and I have been riding the struggle bus on it. You guys will see it in a couple of weeks. And I needed another video topic fast. And if it wasn't for Element, we'd probably still be figuring out what to do it on, or used a canned episode, which not a huge fan of. So thank you, Element 256, for your assistance in allowing me to tell you about our sponsor, 3D Musketeers. Remember, if you are trying to get prints made in everything from regular PLA all the way up to Ultem, you can reach out to the pros at 3D Musketeers. Over 40 3D printers and over 40 years of combined experience. The pros here at 3D Musketeers can help you go from art to part as quickly as possible. We also have a wide range of 3D scanners, from the Artec Spider all the way up to the Artec Ray, and quite a few others. I have a whole playlist for 3D scanning. It's in the card. Take a look. I think you'll enjoy it. But we have the pros and the know-how to get your parts made fast, affordably, and efficiently. So if you do need to get some 3D printing or 3D scanning needs done, reach out to the pros at 3D Musketeers. Links are in that description down below. And if you want to support the efforts that we do here on the channel, but you're not looking to send us any work, but you want to kick a couple of bucks into that creator fund, you can do so by joining Patreon or YouTube channel members for as little as $1 a month, and that money goes directly into making these videos possible. Thank you to all of our Patreon and YouTube channel members that do this kind of thing. Without your support, we wouldn't be able to make videos like this as often because, wow, it's tough. There's a lot of burnout. There's a lot of burnout very quickly. I'm working on it. I promise. We're getting there. But I do enjoy the hell out of it, and thank you to those of you that make this possible. It's a long journey, and we wouldn't be here without you all. And if you aren't looking to contribute any money, totally understand. A like, comment, share, and subscribe. It goes a long way to helping the channel grow. Let's get talking about filament. Here on the table, we've got a pretty decent spread of filament, all the way from Polyterra, which is a mix of PLA and I'm fairly certain PHA, although Polymaker is not very public about it. This is a pretty dense PLA. It's about 1.31 grams per cubic centimeter, which I've unfortunately learned the hard way when I tried to do a print that was 500 grams of PLA at 1.24 grams a cubic centimeter. It ran out of filament on the second one. And I thought the rolls were short until I realized, no, it's actually just a little bit more dense. Polyterra is a nice starter material, but some of you might not like that soft touch feel that it has to it. It is also relatively weak when it comes to interlayer bonding. That is the bonds between the layers. Remember, 3D printing is weakest about the Z-axis, so as your parts get taller, they are also gonna be easier to break. So make sure you orient your parts correctly. Video on that one coming soon as well. In that same family of interesting looking, but you know, not all that strong, are gonna be your silk filaments. This is a King Rune Silk Rainbow. Real pretty colors that we have on this one. This is their Cosmos color. Silks have become pretty popular recently, and some have said that the actual thing that makes it shiny is polycarbonate, although I'm not sure. I'm not a material scientist and I have not done my research on the silks. Silk filaments are really only to be used as something that looks good. They are not for mechanical purposes. They are not strong and have similar issues to Polyterra. We then go into our glitter filaments. This is a Polymaker Galaxy Dark Blue, and Zombie Hedgehog's favorite color. And as you guys can see, it is a dark blue translucent with a bit of silver metal flake in it. I like the sparkly, shiny filaments. It makes your parts look really pretty. But again, the problem is, and this is a weird one to think about, but work with me on it. The glitter makes it weaker, because you are removing plastic and replacing it with glitter. Moving on from glitter filaments, glow-in-the-darks. I don't actually stock glow-in-the-dark filament here at 3D Musketeers because it's not one that we get a lot of questions for, and it's not one that I like printing. Glow-in-the-dark filament is abrasive. It uses strontium aluminate to get you that beautiful glowing color. And in fact, Stefan of CNC Kitchen just did an awesome video going through different glow filaments. We'll link to it in the description down below so you guys can go take a look at it. And if you do want to see all of the filaments, Zach Friedman has an awesome series going through all the crazy different filaments out there, including some of the upper tiers that we're going to be getting to here in just a minute. Zach is a good friend of mine as well, and good luck on the move, Zach. We're rooting for you. But then we have our regular PLAs. This is Red Ice from Printed Solid, the Jesse PLA, and it is a translucent red. I love Jesse PLA. I've said this before and I'll say it again. I think Printed Solid makes some of the best filament for the money, period. Recently, I did tour Printed Solid with the Better 3/4. We did an entire video about how filament is made. We'll card to that and link to it in the description so you guys can take a look at it as well. Regular PLA is good for pretty much all printing under 140 degrees Fahrenheit or 65 degrees centigrade. The darker the color, the more sensitive it is to temperature. Black filament will absorb more heat faster, causing it to warp in even a relatively cold day because the sunlight is being absorbed. That infrared radiation is being absorbed by the black coloring more than a lighter color would. So if you are going to put parts into cars, PLA, probably not the right material. The nice thing about PLA is while it does eventually uptake some water, it is relatively slow compared to other materials in terms of getting wet. So you know how in Print Fix Fridays I get upset because people just instantly blame wet filament? It's not normally wet filament. One of the easy ways to know if your PLA is starting to get a little bit damp is to see if it breaks. If it snaps really easily, it is getting a little bit damp and you might benefit from drying it out. The other benefit of PLA is that it is corn-based, polylactic acid. And so it is reasonably biodegradable. It does only biodegrade under ideal circumstances. Don't just stick it in the ground. If you don't have a compost heap, it's not gonna biodegrade it. Even if you do have a compost heap, it's probably not perfect conditions. So it is safer for the environment, especially when you look at some of the other ones here. But as a whole, it is the less damaging plastic here on the table. And because it is corn-based, it has a pretty sweet smell when you are printing it. Just don't sniff your filament when it's printing. One, that's how you burn your nose, and two, if you can smell it, it's probably putting microplastics into the air. I'm not an expert, but where else would the smell be coming from other than VOCs? PETG is a material that we choose to use if it needs a little bit extra heat. PETG is, to me, the love child between PLA and ABS. ABS is a terrible material. We're gonna get to it in a minute. I have one of the worst types down here. But PETG takes the best of both worlds. The printability of PLA and the close enough temp resistance of PETG. This is good up to about 85°C or about 185 degrees Fahrenheit. In most cases, PETG is totally fine in cars. I love PETG. However, it is notoriously sticky and stringy. PETG does uptake water relatively fast, but it takes a long time for it to be very damaging. But PETG by nature is just a stringier plastic and is a little bit pickier to print. If you have mastered PLA and are looking for a little bit of a further challenge, PETG is an awesome way to go. It's not generally much more expensive, and on deal can sometimes be less money than PLA. Now, the nice thing about PETG is there is already established methods for recycling it. You can put it with any regular soda bottle because it's the same material. But if you are going to recycle it, make sure that you wash and clean your parts of any glue, hairspray, or other contaminants, because that will taint the recycling process. This is my favorite PETG, with this one being my second. This is Starry Night by Atomic, and Atomic has one of the coolest spool designs. Looks like an atom. You gotta love it. And then this is the Mystery Orange from Printed Solid, which is pretty much Prusa Orange. And I do like it. I love Jessie PETG, although what we find for most of our clients is that PLA does 85 to 90% of the jobs that we do. And if they need something more, PETG is not normally that something more that they need. They need something from this pile. This is FRABS. Fire Retardant ABS. This is from 3D X-Tech and their Firewire series. I love this material, but my God, do I hate printing it. The fire retardant additive that is used in this process is one of the most pungent smelling things I have ever dealt with. I made the mistake of printing this inside the shop and was banished within a few hours to print it literally inside of my laser, which sits off of here, and every few minutes we would turn on the exhaust system to get the fumes out. I do not know what the smell is, but I will tell you it is heavy and it sticks into clothing. Anyways, beyond the fire retardant aspect, ABS is one of the most common plastics on the planet. It is made of literally liquefied dinosaurs. It is oil-based. That is why I don't like it. It is non-renewable effectively, right? We will eventually run out of oil for ABS. I prefer more of the polymer-based, but ABS is a very easy material if you have the right printer. The benefit to ABS is that it is relatively thin. At 1.04 to 1.07 grams per cubic centimeter, its density is much lower than that of PLA and PETG, which have roughly the same. So when you look at people that are doing speed benchies and they're trying to print as fast as possible, often you will see them printing with ABS because it is one of the easier materials to extrude in the 3D printing process. One of the downsides to ABS is that it hates cooling. Where PLA and PETG will take all the cooling you can give it, although sometimes PETG can be a little bit picky, ABS hates air. It wants to be in a sealed environment with a heater if you can, and if you can't, keep an eye out. We are in now stage 5 of prototyping of the Politician, which is our system for filtering and producing hot air. You know, like a politician. Right to jail. And that will allow you to have a chamber like a Wham Bam Hotbox, code Musketeers 2022. Yes, it's still 2022. For 10% off of your entire order over at Wham Bam, you could add a politician to a hot box and get yourself a temperature controlled chamber for very little money, which is pretty darn cool. ABS does not like cooling at all. And even on printers like the Bamboo Lab X1 Carbon, it uses minimal, if any, cooling. Generally speaking, the hotter you can print ABS, the better. It likes to be around 255 C and above, which means it's on the upper echelon of what is physically possible with non-all-metal hot ends. Generally speaking, I would never print ABS on a printer that does not have an all-metal hot end and is not explicitly stating that it can handle those kinds of temperatures. You want bed temps around 100 to 110 degrees centigrade, which is literally hot enough to burn you. So be careful. Nozzle temps, of course, anywhere between 240 and 265, depending on the material. PLA likes it relatively cold at about 215 on the nozzle, 60 on the bed. PETG likes it a little bit hotter, 240 to 260 on the hot end, and about 75 to 90 on the bed itself. ABS, though, hates cooling. We only add a little bit of cooling when we do bridging to allow that material to actually shrink as we need it to get really fancy bridging. But you'll notice on some prints, the layers might start to separate. That is because as ABS cools, it tends to shrink. It is common that if you're going to be printing ABS, that you add 0.5% and scale your parts up ever so slightly because that material is going to shrink. Now, each ABS is a little bit different, so you will have to tune it in, but slicers do not currently compensate for that, at least the open source ones. ABS, though, is pretty much the all-around material. It's good for low temp applications, high temp applications, although at above 100 degrees centigrade or so, it's time to look at a different material. But if you're running above 100 degrees centigrade in your needs for the materials, you're probably not looking at printing with a relatively affordable printer anyways. You'll start to get limited very quickly into what machines that you can and can't use. But ABS particularly is very picky about orientation. Remember, 3D printing is weakest about the Z-axis, and we're gonna be doing a video on orientation coming soon. But this stuff is really tough because ultimately, it is not very strong on the interlayer bonds, and it is often recommended that you anneal it, which is a post-print baking cycle, to let the stress out of the filament itself. It will cause warping, so you have to be very careful if that's a thing you're going to do, because you have to really control the system well. ABS has a more fun cousin, or that crazy uncle that we all have, called ASA, which is still a styrene-based plastic, so it is oil-based. But unlike ABS, ASA is UV stable. So if it's gonna be an application where it is outside often and needs to handle some heat, like a part to go on a dashboard of a car, ASA would be your choice, where ABS will start to crack over time. Those of you with old cars and your dashboards are cracking, it's because it's ABS, and the ABS is finally degrading enough to where it is splitting as it is heating and cooling throughout the cycle of the day. Now, there are carbon fiber variants of most of these materials. This is a carbon fiber filled PLA from 3DX Tech. I love carbon fiber filled materials. They make some of the prettiest parts on the planet. I mean, absolutely gorgeous. The layer lines just cease to exist. And while the parts are technically weaker, you can utilize the carbon fiber because it does add some stiffness. And no, this is not like you're making panels for a Bugatti or a Lamborghini or a Ferrari. That is woven carbon fiber. This is just chopped carbon fiber that is thrown into the hopper as it is extruding the filament. With certain companies, you might just get carbon fiber dust, where in others you will actually get long strand carbon fiber. With 3DX Tech, you get long strand carbon fiber. Now, you do pay for it. It is a little expensive, but if you're looking for quality material, I do like 3DX Tech when it comes to the exotics. But the carbon fiber does not really provide you with any further benefits other than it adds a lot of rigidity. So if PLA is even too flexible for you, a carbon fiber PLA will be considerably stiffer. Just understand, you will need a hardened nozzle to do it. My preference is to go to a ruby or a diamond nozzle, which we talked a lot about the diamond nozzles. We'll link to that playlist up above. You'll never damage either one of those by running material through it. You might damage it because you did something stupid, probably won't damage it from just running materials through it. And they both have lifetime warranties in the case that you, for some reason, run thousands of kilograms of carbon fiber material through it. There is also glass fiber filled, and if you look at the two side by side, you'll notice that the glass fiber is quite a bit shinier than the carbon. That's because glass is shinier than carbon. I know, crazy. This is the Max G glass fiber reinforced PETG from 3DX Tech. And I will say, if you want some really pretty carbon fiber, Atomic makes colored carbon fiber PETG and PLAs. My gosh, they are pretty. I don't have any, but I would love to get some. So Atomic, slide into those DMs or something. I do like the glass fiber, although I don't use it very often. Most people want carbon fiber because it's got the name. I happen to find glass fiber to be a prettier material when it's printed. Similar to carbon fiber, it's got the same deal, right? It is a weaker part, but it is stiffer, which gives you sometimes a higher tensile strength, but way less flexibility. You can use that to your advantage though. And this is where I would do it. This is carbon fiber nylon. In these bags are materials that are incredibly hygroscopic. Nylon, just opening it out here, it is over 70% ambient humidity right now in my garage in Florida. It's damp. I would need to dry this for hours. These are resealable sous vide bags. We'll link to some in the description down below. They're okay. I don't find that they keep all the moisture out, but they definitely do a better job than a standard Ziploc baggie. So, you know, grain of salt where you can. Carbon fiber nylon is one of the top tier materials that you would use on a standard 3D printer. You can get regular nylon. I have some inside. It's a good material, but I always prefer the carbon fiber filled variant of nylon for one specific reason. Nylon sucks. I hate printing in nylon, and those of you that have printed in pure nylon know exactly what I'm talking about. It is like ABS on steroids. It is way hotter to print. It warps so much more. It is incredibly hygroscopic. Carbon fiber filled, the warping pretty much disappears. You'll get a little bit, but nowhere near as much as you would when you're dealing with the raw materials. So the carbon fiber filled is amazing. We will do a video coming up going through the regular materials and their carbon fiber filled variants, just so you guys can take a look at the parts themselves, but probably only once we have the politician really dialed in, because I think it would be really cool to have open air, enclosed, politician enclosed, to show the difference in what they look like. And I have enough identical printers that we can do that. So make sure you get subscribed. Nylon, though, is pretty much the top dog. There's only one to me that is better when it comes to impact resistance, and it's polycarbonate. But nylon is what a lot of people will say they want, but don't actually know that they can totally get away with PETG. Nylon needs very hot temps. You're talking very similar to ABS temperatures, but with none of the ease of use. What I love about carbon fiber nylon, though, is it is damn near indestructible. You can make a part out of carbon fiber nylon and give it to somebody. They're gonna think it came off an injection molder, first off, because they're not gonna see the layer lines at all. And two, it just feels stiff. It's got a presence to it. But be careful, especially with the carbon fiber and glass fiber filled. 0.4 millimeter nozzles are just asking for problems. Go with a 0.6 or above to keep the clogs at bay. Especially the quality stuff, this 3DX Tech material, the strands of carbon fiber are often long enough and large enough to clog up a 0.4 millimeter nozzle. Ask me how I know. But at a 0.6 or above, you should be running it just fine. What we do find is that carbon fiber nylon specifically prefers thicker layers. I don't know why, it's just my personal experience with it. Let me know if you've had experience with carbon fiber nylon and what you found. I personally do not print this below 0.25 millimeter layers, but realistically, you can go up to 0.35, 0.4, 0.5 millimeter, and you still won't see the layer lines anyways, so it doesn't matter. And something to note about those taller layers, it does make your parts stronger most of the time. Because you're putting out more material, there's larger surface area for everything to grip onto, and it's hotter for longer, which gives a better interlayer bond between the materials. Stefan of CNC Kitchen has been through this before. We'll link to his video in the description where he goes through different layer heights, because there is a diminishing return as well as extrusion widths, because that's the same deal. You can go a much larger extrusion width on something like carbon fiber filled and take up a lot of the benefit of having that extra strength and really get past some of the downsides of losing that flexibility. Raw nylon, you can bend. It's like TPU right here. It's a weird material because it feels like it's gonna break, but it never really does. It's a crazy material and I love it, but I prefer its fiber-filled cousin personally. If you are looking for pretty much the top dog of materials, polycarbonate and carbon fiber filled polycarbonate would be what I recommend. This is Polylite PC from Polymaker. Similar to nylon, you look at it the wrong way and the damn thing's warped on your bed and everything's gone to hell. But it is not as hygroscopic. It will absorb water nowhere near as fast as nylon, but it will become wet relatively fast. The thing that I find with polycarbonate is it is harder to bake the water out of polycarbonate than it is nylon, because polycarbonate really likes to print up near 280 to 290 C. It's not fun to print with. I do like that polycarbonate is relatively odorless comparatively. ABS just stinks. Styrene-based plastics stink. Polycarbonate or PC is relatively nice. To be clear, this material is darn near indestructible. I've seen people print parts with this that can take strikes at well over a few thousand feet per second by very small, very fast moving lead projectiles. But polycarbonate is when you need pretty much top tier everything. It is not as flexible as nylon, so you get a benefit in that it's a little bit more rigid, but it is still very flexible when you look at the other materials on the table. The one thing I don't like about polycarbonate is without an interface material for your support, it just pretty much bonds the supports. It is really rough to work with in that way. So if you are gonna print with polycarbonate, make sure you either have your supports really well dialed in for it, or you have a tool changer, an IDEX, or you don't mind wasting a bunch of expensive filament, if you're gonna do something like maybe the AMS from a bamboo, where you're gonna purge out one material for the other. That is my one qualm about it. Even nylon, I find I can get it to break off pretty cleanly. For some reason, me and polycarb are not the best of friends, but it is a material that once you print it, you'll probably never need to make another one again. Polycarbonate and nylon are notorious for destroying build plates, especially ones that are made of PEI. This is PEI. We'll get to this in just a second. Polyether imide, for some reason, bonds to certain plastics. This includes, oddly, PETG. We use a barrier of Windex, hilariously, and it seems to work quite well in our prints, but with nylon and polycarbonate, we absolutely use glue stick. And that's not to keep it stuck down, it is to allow it to come off of the build plate without damaging it. On our Fusion 3 F410, it has a big glass build plate. And that is actually my preferred material for printing these two types of materials on, because it doesn't weld to it. And if it does, glass is way cheaper than PEI plate and also a lot easier to replace. You just take the glass plate near a trash can and you smack it with a hammer, and then you scrape the glass off your part and you're done. If it's stuck to PEI, you then have to peel the whole sheet. It's a pain in the butt. So be careful with that. Prusa actually sells dedicated plates for their nylon material. So if you are gonna be printing with nylon and you have a Prusa, take a look at getting that specific nylon build plate. I don't have one, so I don't know how well it works. I've always used the smooth plates and it works fine for me. But don't take any risks unless you're willing to risk it. Next up, we've got TPU, which is kind of an odd material. It comes in all different durometers. This is just a generic semi-flexible TPU. It is really stretchy and pretty much has a hard time breaking. The one downside of TPU is that it has very poor interlayer bonding. It is pretty easy to tear apart the layers themselves, but trying to rip the filament apart, like as a solid string, is very, very difficult. TPU is great for impact resistance. We'll see people making custom insoles out of this. When I was walking with a cane, my cane and handle was actually TPU printed because I like food and the standard cane handles kind of suck, so I made one that utilized a design off of my own hand and printed it out of TPU. And after a couple of years, it still works well, but I have noticed some of the layer lines starting to fail. TPU is nice, but the thicker you make it in terms of wall thickness, the stiffer this material gets. I highly recommend using gyroid infill when you're printing with TPU. That is because gyroid is the exact same strength in X, Y, and Z, as long as you have the same amount of wall thickness. So if you are using 5 top layers at a 0.2 millimeter layer height, you need to make sure that your walls are roughly the same thickness, then your part will be squishy the same way all the way around it. That's a nice thing to know about TPU. TPU is interesting because it doesn't really bond to any of the other materials on the table. So it actually makes a great support material interface. There are other support material interfaces out there like HIPS.
You know my hips don't lie, and I'm starting to feel it's right.
HIPS is high impact polystyrene, again, styrene based plastic. HIPS is a dissolvable support material, and it is used often as a breakaway and soluble material for ABS, PLA, PETG, because it can print at pretty wide range of temperatures. Then you also have PVA, polyvinyl alcohol, otherwise known as school glue. It's the same material. PVA is school glue. Now, the PVA filament that you might use might have some extra herbs and spices, if you will, and that makes it water soluble, but not as delicate as, extruding out of an Elmer's glue bottle 1.75 millimeter filament. No, you're not going to break the filament market by somehow learning how to extrude Elmer's glue into 1.75 millimeter filament. Jean from Proper Printing, I'm looking at you. I want to see you do that. You finally got your resin FDM printer working. Now it's time. I want to see turning Elmer's glue into filament. That would be cool, because you do those crazy things. Love your channel, dude. Links in the description down below. But yeah, TPU is one of those materials, like, people think they can make phone cases out of it. Don't make a phone case out of TPU, please. There's a reason why we use injection molded cases. They're just better. And I know that it's cool to have a 3D printed phone case, but don't rely on it to protect your phone. Be careful there. TPU does come in different flexibilities, all the way down. I think I've seen as low as like 60 or 65A, but most semi-flexes like this are in the 75 to 90A range. Smooth-On has a great anecdotal knowledge base for durometers. We'll link to it in that description below. That shows you where certain things lie in that area. So when you are printing it, remember, the thicker that you go, the higher effective durometer you work with, because it does get stiffer the thicker the part is. It's a cool material. Its uses are somewhat limited because it is very difficult to print, because as it looks, you're pretty much trying to push a rope, and that is very, very complicated. And finally, the most complicated material on the table. This is a very old spool that has broken of Ultem 9085. Ultem has the technical name of polyether imide, otherwise known as PEI. It is a material that is one of the few materials that is certified for flight by the FAA. If you are able to print this material right here, you can put it into an airplane and it is certifiably totally fine. This material is fire retardant by nature and runs somewhere in the range of $200 to $600 a kilogram. It is the most expensive material on the table, and hilariously, it's on a printed spool, which I find funny. This is a sample that I've had for quite a few years, and I only really ever use it for demonstrations because people don't believe you when you tell them that it is never going to burn. It just carbonizes. It's very, very cool material, but it needs a specialized printer to print it. You need to get well above 300C, well above 150C on the bed, and you need your chamber to be at least 100C. In most cases, stepper motors are gonna be dead by then. The actual heat will cause the magnets in there to fail. That's bad. So in a lot of cases, printers have the motors either on the outside or they have some sort of system to cool the motors, be it with a liquid cooling system or something else. I do love Ultem. This is just the sample spool that we use, and we have a couple of machines that are capable of printing it, but I will tell you, boy howdy, it's expensive. Not only because it has all the certifications, but it takes a long time to get chamber temperatures up to where you need Ultem to be, and then even longer because Ultem is one of the few materials that does require annealing if you want it to be to its full strength. But there are a lot of benefits out there for materials, so don't just look at this and say, wow, all these materials are cool, I'm gonna go out and buy them. To be clear, outside of the first few that we talked about, the prices go up very quickly. With Polyterra being in the $20 to $25 range, Jessie PLA being $20 to $22, Atomic being $33. And then when you start getting into the nylons and polycarbonates and all that, your prices go $50, $60, $70, $80, $90 very quickly per kilo. Although hilariously, TPU is like 15 to 20 bucks a kilo. It's generally one of the more affordable filaments on the table, but it's also one of the tougher ones to print. Remember, if your filament is filled with basically any material other than wood, you should be utilizing a hardened steel nozzle minimally or one of the higher ed nozzles available out there. Do not use stainless steel. It's not hardened and it won't last. But filament is awesome, and you get so many opportunities and options out there to really build your part with the right material for the right situation. And it's why when people come to us and say, we need nylon, I ask, well, can you tell me about the project? Because if it's just a decorative part, then they could probably get away with PLA. If they say they need ABS, then they tell me that it's a functional part used outdoors. I'm gonna recommend ASA instead. I know this might be weird, but the customer is not always right when it comes to material choices. Mess around, right? PLA is cheap. PETG is cheap. ABS is relatively cheap. The carbon fiber fields start to add a little bit more price to it, but you're not gonna spend a bunch of money to learn. Now, if there are specific materials that you guys wanna see, let me know in those comments down below, and we'll make sure to either bring them in or do dedicated videos on them where we talk a little bit more about the chemistry behind it, why they're awesome, and why they also kind of suck. But there's a lot here, and this just barely scratches the surface of what's available. When you start really looking on the bleeding edge of what's possible for filaments, you look at companies that are putting graphene, graphite, ceramic, and other materials, including metal. There's metal filament. It doesn't need to be sintered so that it burns off all the plastic and goes back to pure metal, but that's friggin' cool. I don't care who you are, that's just friggin' cool. I kind of love filament because it allows one machine to be incredibly versatile when you look at different opportunities for what's possible out there. Whether you're going for something that just simply looks pretty, or something that needs to be incredibly hard and functional. FDM or FFF kind of has it all. But let me know what you guys think in those comments below. I would love to do a series a little bit more in depth about different materials. So let me know if there are certain ones you guys want to start with, and maybe there are ones that I've missed, because that's totally possible as well. That's all I have for you guys today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Hey guys, real quick before you go, the Sanjay Mortimer Rep Rap Festival, or SMRRF, is coming up in December of this year, the first annual event over in the UK. This is put on by E3D at the Examination Schools, University of Oxford. It's gonna be an awesome party. It runs from December 2nd to 3rd of 2023, and we are looking for sponsors to take us over there, because if we can get that, I will shave my head at the Sanjay Mortimer Rep Rap Festival, and we will donate every dime that we raise for it at that event. But it is a incredibly expensive trip. At least currently, I don't want to do it without a sponsor backing us, because if I'm going to shave off my hair, I want to do it, one, for charity, for Sanjay Mortimer Foundation, and two, have a sponsor that we can shout out during it as well. So if you are interested in doing that, let me know. You can hit up those DMs or email us, youtube@3dmusketeers.com. Anyways, outro time. Hey guys, thanks so much for watching this video. And a massive thank you goes out to all of our Patreon and YouTube channel member supporters whose names are listed right next to me at the $5 tier and higher. Thank you for what you all do in making these videos possible. And if you are looking to join, we have links in that description down below where you can join for as little as $1 a month to help make these videos possible multiple times a week. Right below me will be the entire beginner series where you can learn about 3D printers, how they work, how they break, and how to fix them. And right next to that will actually be the first time that I talked about Filament a long, long time ago. I'll see you guys down in those comments and in the next one. Take care.